subset is I look upon this as handlebars of a bicycle, right? And so that means that B is holding the handlebars, and therefore B is controlling A. Right? That's my trick to remember. And so that means that B is the boss, right? So B is the bigger one, and A is your subset. So B is your set, right? Because the handlebars are this way. I mean, I toss that as a suggested way to remember which is which. Which one's the set and which one is the subset? Well, the boss, the one that controls the handlebars, is the boss, the bigger one. So this is the set and this is the subset, right? Now, A is said to be a proper subset if this underlying bar here is missing. This here. So you just write it this way, okay? Now, in the textbook, Sipser claims it's written this way. Well, frankly speaking, now he's a computer science guy, right? Not so much a mathematician. I've never seen this before in any other math book, and you know, I do a lot of math, so I just put it in brackets. Usually, it's just written this way. Okay, so if A is a proper subset of B, the missing bar. The bar here is missing. Like here, this A is a subset of B. Now that means that A could be equal to B. That's strictly true. In fact, like these two lines here sort of look like an equal sign. Right? That's why you have this bar underneath. So A could be a proper subset of B here, but also it could be equal to B. Right? So if you want to say that A is strictly its size, number of elements it has, is less than B, in other words, a proper subset, then you write it this way, without the underlying bar here. Right? Just the C, well, all right, okay. So proper subsets define A is a subset of B, but A is not equal to B. Right? That's a formal definition of A as a proper subset of. Right? In other words, it doesn't have the same members. That's a bit ambiguous, meaning it has less members. All right. Now about sets, a few comments. The order, like if I wrote 21,757, it's the same set. Okay. In other words, the order of writing them irrelevant. Doesn't matter. The order is irrelevant. And what about repeats? If you have repeats in a set, like you got the element 2 mentioned twice, throw out the repeats. Okay, so no repeats in a set. And since the order is irrelevant, then these two sets, set of elements 1, 2, 3, and 3, 2, 2, 1, are the same set. They're equal to each other because you can throw out a repeat. The 2 is repeated, so throw out the repeated one. So that'll leave you with 3, 2, 1. And you can change the order of that because the order is irrelevant, so that you could have that become 1, 2, 3, but that's the same as that. Okay? So these two sets are the same. Even though the number of elements in a set, strictly speaking, here's 4 and here's 3. But you've got to repeat, so throw it out, so size is the same. You can change the order, and so you get the two elements are the same. Right? So repetitions, if repetitions, repeats, are relevant, then you don't talk about sets, you talk about multi-sets. Right? People don't talk about multi-sets much, so you can pretty well forget about that. Talking sets in general. Alright, sets can be finite or infinite. A finite set has a finite number of elements or members. Okay, an infinite set has an infinite number of, has infinitely many elements. Right? Now you cannot write out an infinite set in terms of writing out all its elements. Right? By definition, it's infinite. You can't do that. So the way you write an infinite set, one way, is to use ... in like etc. Right? So, for example, if you wanted to write out the set, now it's an infinite set, right, of natural numbers. What are the natural numbers? Well, by definition, they're the counting numbers, like a little kid in kindergarten learning to count. 1, 2, 3, dot, dot, dot. Right? So, and that set, that infinite set of the natural numbers is written capital N. Okay, here. So this is a very common symbol used in pure mathematics. So we will use that a lot in this text, N, capital N. Right? And if you're writing it out as a set, you write curly brackets as usual, 1, 2, 3, dot, dot, dot. Okay, so the continuation symbol, if you write, the etc. Now here are some more very useful symbols that get used a lot in set theory. Capital Z, or Z, if you're from... Which countries say Z? Britain and the colonies, I guess, British colonies. Well, America was a British colony, but America says Z. So which ex-former colonies still use, say, Z rather than Z? Canada, I don't know, probably Americanized, they probably say Z. Australia says Z, unless they've changed recently, because that's where I grew up. Hong Kong says Z, I think. Anyway, so I will use a mix of, I mean, I've lived in 3 English-speaking countries, so my English is a mix of all 3 influences. So I grew up in Australia as a kid. I've lived in Britain long enough to take out British citizenship. My passport is British. Well, I'm dual actually, Australian and British, so I have 2 passports. And America. So lived about 5 years in America as well. So you're probably hearing more British accent than anything, because I was young. It's more formative influence. I think I've picked up the American R to some extent, and I've picked up lots of American idioms. So I probably speak in an American style in terms of the choice of words that I use and phrases, but my accent is probably more British. But if you're British listening to me, you're probably hearing quite strong doses of strong, meaning the Australian accent. So a mix, a real mix. Okay. Sometimes when I was a prof in America, I'd say something which I thought was just ordinary English, and my class would just stare blankly, and I'm asking myself, what I just said, was that Aussie or Brit? So I didn't understand what I was saying. But to be honest, my graduate classes were, well, if they were master's level classes, they were mostly from India, and if they were PhD level classes, they were mostly from China. And that doesn't surprise me. Oh, by the way, I should tell you, I am PR, I am not PC, I'm not politically correct, I'm politically realist, PR. So I state, maybe undiplomatically, but nevertheless scientific, as I see it, scientifically based views. And I've read that the average IQ difference between Chinese and Indians is 20 IQ points. So Chinese, Northeast Asians, they're the brightest large group in the world, average IQ of 105, whereas the Indians are part of that great swathe of humanity, if you look at the world IQ map, at 85, so quite a bit dumber. Average Indians are like the average blacks in America, also 85. So it doesn't surprise me that the PhD students were largely Chinese, because the populations of those two are much the same. And the mentality of the Indians wanted jobs, whereas the Chinese were more longer thinking, smarter, and they wanted good jobs. They wanted money too, of course, because